In this proof, I'm going to prove the statement, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Keep in mind, because I'm proving this statement, I can't actually use that statement to do my proof. So I'm going to use the base definition of a parallelogram, which is that both pairs of opposite sides are parallel. Go back to that original definition. So my given has those segments bisecting each other. And the first thing I'll note here is that I can prove two pairs of triangles congruent. I've got this pair of vertical angles congruent here. That's angle AEB congruent to angle DEC. And that, of course, is that vertical angles are congruent. And I also know that its second pair of vertical angles is also congruent, these other sideways vertical angles. So that's angle AED congruent to angle BEC. So I'll list those as well. And now I can actually prove the two sets of triangles congruent. I can prove triangle AEB congruent to triangle CED by side angle side. And likewise, I can prove triangle AED congruent to triangle CEB also by side angle side. So now I have two sets of congruent triangles. I can use any sides or angles from those triangles. What I'm going to do here is I'm going to show that the alternate interior angles forming this Z shape here are congruent. That angle there and this angle down here, and that's going to prove AB and DC parallel. So angle BAC is congruent to angle DCA. Those are corresponding parts of congruent triangles are congruent. And I have a sideways set of alternate interior angles as well. That's angle ADB and angle CBD. Angle ADB is congruent to angle CBD. Those are also corresponding parts of congruent triangles. And those pairs of congruent alternate interior angles are going to show that line AB is parallel to CD. Because congruent alternate interior angles implies parallel lines, and AD, oh, gotta be careful there, sorry, these two lines are parallel, and AD up here you can see is going to be parallel to BC for the same reason, also congruent alternate interior angles. So that line's parallel to that, this is parallel to that, and as a result I've showed both sides of opposite sides parallel. So ABCD is a parallelogram, and I'll say if a quadrilateral has both sides, both pairs of opposite sides parallel, then it is a parallelogram. And that completes my proof of the theorem that states that if the diagonals of a quadrilateral bisect each other, then it must be a parallelogram.